Let's start by reviewing a few rules we learned in the last lecture. We have seen log of any number to itself as the base is 1. Log of 1 is always 0 irrespective of the base, and log of b to the power n to the base b is equal to n. Let's extend this last rule. What if it were log of a to the power n to the base b? It will be equal to n times log of a to the base b. We could look at it visually like log of a to the power n to the base b. The exponent n moves ahead of the log and the value will be n times the log. Let's continue with a few more simple rules. Log of x plus log of y can be written as log of x into y. This is sum of logs is equal to log of products. What happened to the base out over here? Whenever the base is same for all the logs and is irrelevant to the context, we can ignore writing it. But do remember, this rule is applicable only when the base is same for all the logs. Let's say b, as you can see now. We have a similar rule for difference of logs. Log of x minus log of y can be written as log of x divided by y. We can club the two rules and form a longish expression. For example, log of x plus log of x minus log of y will be log of x into x divided by y, log x square by y. Beginners have a little confusion here. Let me highlight that. Consider log of x into log of y. This is a product of two logs. This cannot be simplified further. In the next slide, we will see product of logs in an interesting result. However, let me highlight it again here. The two logs that are being multiplied have the same base, b, as you can see now. If the base is same, we cannot simplify this further. In the next slide, the base will be different when we are going to multiply the logs. So what is the confusion? Remember, log of x into y. Here it is log of a product. Can be written as log x plus log y, but log of x into log of y cannot be simplified. Let's take up a question based upon these rules. What is the sum of 10 terms of the expression that you can see? Pause the video, attempt it, and then continue. We see that the expression is the sum of logs, log plus log plus log. So we could write it as a log of products. That is log of m into m square into m cube and so on divided by n into n square and so on. Which, using rules of indices, will be log of m raised to 1 plus 2 plus 3 till 10 divided by n raised to 1 plus 2 plus 3 till 9. Summation of 10 is 55, summation of 9 is 45. So we are left with log of m raised to 55 divided by n raised to 45. Or this is a log of division, right? We can separate it out and write it as log of m raised to 55 minus log of n raised to 45. The exponents 55 and 45 can appear before the log, and the final answer will be 55 log m minus 45 log n. Another rule, change of base, states that log of a to the base b can be written as log of a to the base x divided by log of b to the base x. X can be any convenient value chosen by the user depending upon the context. An interesting result that follows from this rule is when we have log of a to the base b multiplied with log of b to the base c into log of c to the base d. This is the instance of multiplying logs that I was referring to in the previous slide, but notice here that the base is all different. We can rewrite this expression as log of a divided by log of b into log of b divided by log of c into log of c divided by log of d. Log b cancels, log c cancels, we are left with log of a divided by log of d. Using the same change of base rule but in the reverse way, we can say this is same as log of a to the base d. While you have seen this in its elaborate from here onwards, we just need to see the link and arrive at the result directly. Log of a to the base b, the b is continued into the next log, log of b to the base c, and the two logs are multiplied. So the b and b can be eliminated and we can say is log of a to the base c. This is multiplied with the c is continued, log of c to the base d. So c and c again can be eliminated and directly you can arrive at log of a to the base d. An interesting result based upon the same principle is when we have log of a to the base b multiplied with log of b to the base a. A to the base b, b is continued, b to the base a, b can be eliminated. We can look at it as log of a to the base a. Alternately, we could switch the multiplicants and say log of b to the base a is continued, log of a to the base b, and the two logs are multiplied. So, a cancels, log b to the base b. Whichever way we look, we arrive at log of a number to itself as the base, which is 1. Okay. Looking at this in a different perspective, the product of the two logs are 1. That means that the logs are reciprocal of each other. So, we come at an important conclusion, log of a to the base b is equal to 1 over log of b to the base a. We could have arrived at the same relation even by change of base, as you can see on your screens. Let's look at an example using this rule. The question asks us to simplify the given expression. Pause it, try it yourself, and then continue. What we see here is the logs in the denominator, all of them have a different base. So, our first task would be to make the base same. So, I could write log of ab to the base c as log of ab divided by log of c. I could do the same for the other two terms. Now, the denominators are fractions. So, taking the LCM of the denominators, that LCM itself will come in the numerator of the expression. I will be left with log of c divided by log of c plus log of ab and two similar cyclical terms. The denominator here is sum of logs, which I could write it as log of products. So, the denominator in all the three cases is going to become log of ABC. Since the denominator of the fractions are same, the numerator is simply log c plus log b plus log a, which is the sum of logs, which can be written as log of products. So, I will be left with log of ABC divided by log of ABC, which is 1. Though we have solved this example, we could approach this question in a different way, which will help us use this rules again. So, let's try it once more. I see that the first term has log of AB to the base C. The AB has the part C missing and the base is C. So, I could replace 1 as log C to the base C. In the second term, I have log of AC to the base B. B is missing in the AC. Also, the base is B. So, I could introduce it by replacing 1 as log B to the base B. Hope you get the idea. Right? Now, the denominators are sum of two logs with the same base, which can be written as log of the product. So, I will be left with 1 over log of ABC to the base C plus 1 over log of ABC to the base B and one more term. These are reciprocals. Right? So, I could write them by reversing the number in the base as log of c to the base ABC plus log of b to the base ABC plus log of a to the base ABC, which is sum of logs, which is nothing but log of ABC to the base ABC. Log of a number to itself as base is equal to 1. In the next lecture, we are looking at some more rules which are widely tested and not so simple.